Hey, grade 11s. Today I want to do a really short introduction to our next unit on solutions. For the most part, this is going to be a textbook assignment out of chapter 14. So when we make a solution, we dissolve one substance in another. Traditionally, in our chemistry classes, the dissolving substance is going to be water, and the substance that does the dissolving is called the solvent. In fact, water is such a good dissolver of things that it's pretty much impossible to find it in its pure form in nature. It's always got something dissolved in it. Now, once that something that's been dissolved, the thing we call the solute, the part that gets dissolved is the solute. The part that does the dissolving is the solvent. Together, that's called a solution. And in order to be a solution, you have to have two criteria. It must be homogeneous, which means it's going to look the same throughout, and also it has to be stable, which means if we leave it to stand, you let it sit overnight, it's not going to separate back out into its separate components, it's not going to separate back out into its layers. After today's lesson, I want you to go to your textbook and in chapter 14, see if you can write in your own words, because it's much easier for you to remember that way, the meanings of solute, solvent, solution, homogeneous, and stable. I also want you to look at other kinds of mixtures that can form and how they're different. I want us to remember that these are all mixtures. We're not actually having chemical compounds form when we make a solution. Dissolving is a physical process. Now, if I wanted to visualize this, we could take a look at this picture of two different solutions. Clearly, the one on the left is darker and it is more concentrated. The one on the right is lighter in color and it is more diluted. Now this could be because we have the same amount of solute, the dissolved substance, but a very different amount of solvent. You can see the one on the right here has much more water in it, so it's more diluted. But I also could have put less solvent in per unit of solution. If you try to picture this at a molecular level and you look at the ratio of the dissolved substance, which is the blue dots, to the dissolving substance, which is our pink dots in this graphic, you'll notice that in a concentrated solution, there's a lot more solute per solvent than there is in a diluted one. It's important to notice that both components affect whether a solution is concentrated or diluted. In your notes, you have a little chart that talks about types of solutions. And when we make a solution, all that is required is the two components, the solute and the solvent. Our solute, the part that does the dissolving, can be either solid, liquid, or gas, as can our solvent. Let's talk about some examples of different types of solutes dissolved in different types of solvents. In your notes, I'd ask you to fill in these examples. For example, a solid dissolved in a solid could be something like brass. Brass is copper and zinc dissolved in each other. Both substances are solids, so both our solute and our solvent is a solid. Mercury, which is a liquid, can also dissolve into other metals. It makes a form of amalgam. This would be an example of a liquid dissolving into a solid. We can even get gases dissolved into solid if you consider, for example, old ice cubes in your freezer have the gaseous smells of raw foods that have dissolved into the ice. The smell itself was in the form of a gas, and it impregnates the ice and becomes part of it. In all three cases, these substances never separate when left to stand, and you can't actually see one component separate from the other. We can also have solids, liquids, and gases dissolve into liquids. A sugar dissolving in water is a common example of a solid dissolving into a liquid. Your liquid neo or crystallite solution that you might use to flavor your water would be a good example of a liquid-liquid solution. And a gas, like oxygen, dissolves into water and allows fish to breathe. It is also possible for gases to be our solvent to do the dissolving. Smog is a great example of a solid dissolved into a gas. Liquid humidity, the water vapor in the air that we will often feel on a warm day, would be a good example of a liquid in a gas, and air itself is a gas-gas solution. Air is a mixture of mostly nitrogen and oxygen. From grade 10, you might remember that air is 78% nitrogen and only 21% oxygen, and yet never, even left to stand, will it separate into layers. So after the video today, I need you to go grab your textbook in chapter 14 and try to write yourself a plain word definition for each of these terms. We're going to be using them a lot through the unit, and I want you to feel like you understand them. I also want you to look at different types of mixtures that we can have out there. For example, suspensions and colloids. How are these different from solutions? In our next lesson, we'll be taking a look at how solutions form and different things that can affect how much solute dissolves in a solvent or how fast it can dissolve.